Good afternoon, everyone.
Good afternoon.
Good afternoon, everyone. So today we are here to discuss the presentation on secure KNN computation on encrypted cloud data without sharing keys. The topic only looks difficult, but it's not that difficult. It's just too lengthy to explain, but you'll find it easy. So my name is Niraj Kanjani, and I have with me Brinda Patel, Shruti Patel, and Madhur Chauhan, who will be presenting with me for this topic. So before I begin, I want you to interact with me. I want you to throw loads of questions on us so that we can also learn better. Okay? So we'll start. This is the agenda where we talk about what we'll be explaining today. We'll be talking about cloud computing, cloud data, and security. Security, as you all know, includes encryption, decryption, key, and the secure KNN, which is the most important topic that we are going to discuss today. So, before I start, I'd like to answer a few frequently asked questions. What is cloud computing? If a person takes a flight, goes on a cloud, sits over there, opens their laptop, and does computing, it's called cloud computing, right? Is that right? Is that right or wrong? Yeah, it's wrong. So, cloud computing basically means when we access some remote servers for managing and processing our data that are hosted on the internet, it's called cloud computing. That means we are not using our local hard drives or the local servers or local computers. So that's how cloud computing works, cloud data. When we are doing cloud computing, we store a lot of data on the remote servers. Those data are called cloud data. What is security and how it is implemented? When a security guard sits outside our house, it's called security, right? Yeah, that's right actually. But when we'll be talking about cloud computing, we'll talk about cloud data security. So data security is all about like privacy. We need to take care that the private information and the data of the users is not lost and not leaked and is not going to the wrong hands. So for that we use various techniques which would be discussed today, and we also explain you how this various techniques will be implemented. So this is a brief introduction about what we are going to do today. We'll talk about cloud computing that is more prevalent nowadays. People are switching to cloud computing to share the load for their local storages, and it's actually difficult to keep everything on the local storage because it can get crashed or something can happen to that anytime. So that's why people are now moving to the cloud computing. On the other hand, cloud computing provides the pay-as-you-go storage service. So if you are using a limited quantity or limited size of disk, you'll have to only pay for that. You don't have to pay for the entire disk. So that is where we get means profit. We save money and we get good service. Apart from that, yes, it can be said that the security can be an issue in the cloud computing because we are not putting everything on our what we call as we are not putting anything in our space. We are putting it on someone else's space. So we'll have to trust them for the security and all. But what we can do is we can take our own preventive measures, like we can keep the data encrypted, and thus we can have some security on the cloud servers too. There are various like examples that some things cannot be shared, like income levels, health records, personal information like SSN, driving license numbers. All things are not to be shared with anyone. So we need to make sure that all this data is private and is kept securely. So the goal of the existing traditional encryption scheme is just moving the plain text to ciphertext, and now as everyone knows that it has been done with the same logic, so it is actually decrypted easily. So what we have to do is we have to find out the new ways, the new logics to encrypt our data so that it cannot be leaked easily. So here we'll have Brinda Patel who will be carrying out with the rest of the presentation. Please.
Hello, myself Brinda Patel, and the main concept of secure KNN computation. So KNN stands for the K nearest neighbor computation. So main concept of K nearest computation is to search the K nearest point of the given query point according to same distance, some distance matrix measured, such as the main two algorithm for this is Euclidean algorithm and edit distance. So it will simply find the nearest point of that computation. So main basic architecture of the KNN neighbor is encrypted on encrypted data is there are main three components of the architecture of KNN. So main three components is query user, data owner and cloud server. So data will be in the plain text. So it will in this data owner has a main original data which is denoted by D, and then data owner will generate encrypt that data in the form of K and then it will be shared to the query user. Here Q is stand for query and Q dash is encrypted query. So the intermediate protocol between data owner and data user query user called as a sub protocol. So here main component of this architecture is data owner. So basically practical example of this is Facebook. So if we have a Facebook friend, then it will not discover all our information. It will only give the information about it can't give our own whole information. So it's a basic structure of the data architecture of KNN point query. So we consider the security risk of the realizing the total key to the query key and propose and improve the schema where query user can efficiently conduct the KNN computation on the cloud server but not obtain the full key of the data. So it will mainly contain the data which we allow to give them. So it can't take all the information about us. So the system model is mainly focused on the security and privacy problem of the computer data storage and query server, which involves three types of entities: data owner, cloud server, and many other query users. Here some mathematical representation of this model is given. So the last, according to Euclidean distance, this is a main mathematical representation. So here D stands, D is consisting M distance point P and the data owner process a large private database D consisting of M dimension point, that is P1, P2 up to Pn. In practice, we have D is less than M. So D is negligible and M is a large number than 1 lakh. Encrypted form is given by function of encrypted point P1, encrypted point P2 up to encrypted point Pn. So according to the sequence of Euclidean distance, the formula for this KNN is equals to sigma Pi minus Qj squared. So the main rest of part will be covered by Shruti.
Good morning friends, myself Shruti Patel. Now we will discuss designing goals. Why design is required for secure KNN algorithm. In our model, we consider the privacy of data owner and query user, but not the privacy of cloud server, as it just rents out the huge storage of data and computation power but inputs no private data. So here, encryption and query computation should be efficient and more computation should be done at the cloud server. Now three main focus is data privacy, query privacy and efficiency. Now we will discuss about data privacy. For the data privacy, the dataset D should be private to data owner throughout the outsourcing and KNN computation, and it can be disclosed to the cloud server and any query users. To prevent cloud server from learning the private database of data owner, only encrypted data will be stored in the cloud server. The adversary model of this work can be generalized into the 3 levels. The first level is the adversary only knows the encrypted data set, including read hash and encrypted query point, which is also known as the known ciphertext. The second level is the adversary learns some original points except the encrypted data set, which is known as the known cipher, known plain text, and in addition to the encrypted data set, the adversary also obtains the knowledge about the key that owner reveals to the query user. The second is query privacy. Now we will discuss what is query privacy. The query privacy requires that each query point is privately kept to the corresponding query user during the outsourced KNN computation. Here, we do not consider the security of query points against the collision attack of data owner and cloud server. As the security of query point against the collision attack of cloud server and other query user is similar to the data privacy, while query user reveals her knowledge about the key of data owner to cloud server. And the third one is efficiency. Here, this model will ensure that data privacy, query privacy is an efficient and very practical manner. That is, the above goals of security and privacy should be achieved with low computation cost and communication overheads. Here, encrypted database should not increase the cost of cloud server in comparing to using plain database. Now, we will see about notation, which is used in secure KNN encryption algorithm. Here, D is the private database set of data owner, which consisting the M points. D consists the set of P1, P2 up to Pm. D dash is the encrypted database of D, which is stored in the cloud server. Here, Q is the query point and Q dash is the encrypted result of Q. Here, L by C matrix M, where a matrix M which has L lines and C columns, and X the set of 1 to up to X for the positive integer X. Now we can compute the distance with the help of Euclidean distance formula, which is the D of Pi Q is equal to summation of J equals to 1 to D and Pij minus Qj square. Here P is the plain text, D is the Euclidean distance, and Q dash is the index of KNN of the query P. Now further, Madhur will continue.
Hello friends, I am Madhur Chauhan. I am not used to the stage as a Niraj, but still I will try my best. In my part, I have framework. As you know, framework is like this a such a table. In framework, we have 4 stages. The first one is a key generation. Then second is a tuple encryption. Third is a query encryption, and the last is a outsourcing computation in KNN. Now in a key generation, we all know if we are doing any encryption or decryption, we have a different type of key like a public key or private key. So in a key generation, we are going to generate a key with this stage will be completed by only the data owner. It will take a system security parameter L as an input, and it returns a random security key. Now second is a tuple encryption. In this stage, data owner will locally encrypt each tuple in a D. D is a plain text. Each point is encrypted as a single unit, and P dash is an encrypted item of a P. P dash is an encrypted item of a P. The output of an encrypted database is denoted as a D dash. D dash that is D dash equal to P dash plain dash encrypted upon P belongs to D. That is a plain text. The encrypted tuple will be sent to a cloud server, for a storage and online application such as a key NN query. After uploading the data to cloud server, data owner does not keep any type of encrypted data or a plain data. Query encryption. Taking the query user's private point Q, a security parameter L, and a secret key of a data owner as an input. This stage enables a query user and the data owner to cooperatively encrypt the query point Q such that only a query user obtains the Q dash, which is the encrypted result of a Q. Only a partial information of a key will be disclosed to a query user during the protocol. Outsourcing KNN computation. Upon receiving an encrypted query Q, cloud server compute the KNN of the input query point and return L to the corresponding query user.
I hope you understood what they said. So, I'm here with the conclusion. We focus on the problem of supporting. Oh no, actually, we didn't do anything. The author of the research paper did. He focused on the problem of supporting efficient KNN computation over encrypted cloud data. While they have shared the partial key, and now they will be working on sharing the entire or hiding the entire key and then sharing the data. So. Any questions, suggestions, queries are welcome. Anyone? Thank you for your patience. Thank you for your time. Thank you so much.